Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on exploring spanning tree port rows. So let's go ahead and read our objective for this lab. It says spanning tree STP is a layer 2 protocol that is used to prevent switching loops from occurring on a network with redundant links. This process prevents the flooding of multiple copies of the same packet across a network by placing switch ports into either a forwarding state or a blocking state. Ports in the forwarding state will forward packets to the rest of the network. Ports in the blocking state will not forward packets. So let's read the next one. It says when a switch is powered up, it will broadcast BPDUs or bridge protocol data units to determine which device has the lowest bridge ID. The switch with the lowest bridge ID will be elected as the root bridge. Ports on other switches will be blocked based on their distance from the root bridge. All right, so it says right here, in this lab, you will learn how to determine the root bridge. You will also learn about root designated and alternative port rows. Finally, you will learn how to influence the STP root bridge election process. So as we can see from our lab, we have 3 switches all connected by Ethernet links. And as we can see, one of these switches is going to be the root bridge, and the other ones are going to be basically they're not going to be the root bridge. So we're going to have one switch. One of these ports is going to be blocking to prevent a loop from occurring within this network. And as we can see, we have a sales PC connected off of switch 1 on the fast Ethernet 011 interface. Okay, so let's go ahead and read our commands that we're going to be using within this lab. We have configure terminal, which enters global configuration mode from privileged exec mode. We have enable, which enters privileged exec mode. We have exit, which exits one level in the menu structure. We have show running config, which displays the active configuration file. We have show spanning tree, which displays parameter for all VLANs, contains the VLAN name, status, and ports assigned to it. We have spanning tree, VLAN ID, priority value. This sets the spanning tree priority value. Value must be in multiples of 4096. And then we have spanning tree VLAN ID root primary. And this configures the spanning tree priority value to ensure the switch becomes the root bridge. Okay, so we can see that we have, if we look at the IP address table, we have the sales PC, which has an IP address of 192.168.1.101. It has a /24 subnet mask, and its default gateway is 192.168.1.1. Okay, so let's take a look at our lab task. We're going to keep our topology up here in the top left. We're going to be doing our readings in the top right, and we're going to be doing our configuration down here at the bottom. Okay, so it says task 1, it says determine the STP root bridge. It says in this task you will determine, which switch has been elected as the STP root bridge. So number 1, it says on each switch in the topology, issue the command to display STP parameters for all VLANs. Which switch has been elected as the STP root bridge for VLAN 1 and why? All right, so let's bring up switch 3 as well, because it's not up. All right, so we have all 3 switches up. We're going to start on switch 1. All right, so if I do an enable and I do a show spanning tree, hit enter. So the same thing on switch 2. Let's do an enable. Let's do a show spanning tree. All right, and lastly on switch 3, let's do an enable. Let's do a show spanning tree. Hit enter there. All right, so we're going to start out on switch 1. And as we can see, switch 1's root ID, it has a priority of 32,769. You can see its MAC address, and this is the root ID we're looking at. We can tell that switch 1 is the root bridge because of this output right here. It says this is the root bridge. We can see our hello timers, our max age timers, and our forward delay timer. And then this is the actual specific values for switch 1. We can see switch 1's priority is 32,769. The MAC address is here. We can see the hello times as well, max age and forward delay. Now, we can tell that this is the root bridge because of this output right here. And then also, if we compare our bridge ID which is the specific ID for this switch, and also the root ID, they are exactly the same. As you can see, this is the same MAC address. So this is how we know that this is the root bridge. So let's take a look at switch 2. If we take a look at the root bridge root ID information, we can see that this is exactly the same as switch 1 because switch 1 is our root bridge. And then right here, you can take a look at the specifics for switch 2's priority and also its MAC address, okay? All right, and switch 3, same thing over here. This is switch 3's information on its switch, is MAC address and priority. And this is switch 1's root ID information, okay? So we can determine that it says, why is switch 1 the root bridge? Well, we see that all the priorities are the same on each switch. So all of them are configured with the default priority, but as we can see, it's 32,769, 32,769, and 32,769. But the next top breaker is the MAC address. So we have 00C12. Right here is 00C14. Now, of course, 12 is less than 14. So switch 1 beats out switch 2 in that aspect. And then if we look at switch 3, it has 00C13. And as we know, 12 is less than 13. So that is why switch 1 became the root bridge, all right? So right here it says, what version of STP is running on these switches? Well, if we take a look, we can see that it is running spanning tree PVST plus, all right? So we can see that we're running PVST, all right? Let's see what Boson is going to say. Yeah, we're running PVST plus. Yep. All right. So number 3, it says, given that the lowest bridge ID is an important factor in the election of the root bridge, how is the bridge ID constructed? Well, of course, it has the default priority of 32,768, but you have to add the +1 for the actual VLAN. So 32,768 plus 1 is 32,769. That is how we get this priority value. And then, of course, our MAC address is just the burnt in address on each device, all right? So it says, what is the priority value on each switch? We already went over this. Each switch has a priority of 32,769. All right. And it says, what is the MAC address of each switch? Well, we can see the MAC address of each switch right here. We can see for switch 1 is 000C12893959. On switch 2, it is 000C14613123. And on switch 3, it is 000C13803538. All right. So that was number 5. So let's go ahead and move on to task number 2 in this lab. It says determine STP port roles. It says in this task, you will determine the STP port roles for the ports on each switch. For this task, you will continue to use the output of the show spanning tree command that you issued in task 1. So we do not have to make any changes in the output of the CLI, which is good. All right. It says what port roles exist on switch 1. What can you infer about the roles of switch 1 on the network based on the port roles? All right, so if we go to switch 1 and we look at our port roles, we can see that all ports on switch 1 are designated ports, and that is because this is the root bridge. And if the switch that is the root bridge, all ports on it need to be forwarding so it can send out its BPDUs and also information as well to the topology. This is our root bridge, so all ports have to be in a designated role in the forwarding state. Let's see what Boson is going to say. It says all of the root bridges ports will be configured as designated ports. Therefore, you can submerge that switch 1 is the root bridge for VLAN 1, even if the output identifying it as the root bridge was not available. Designated ports are eventually placed into the forwarding state. This means that PVST plus is allowing the port to forward traffic. Yes. All right. So here it says, what port roles exist on switch 2? What is the purpose of each port role? All right. So let's go to switch 2. And as you can see, fast Ethernet 01 connection which is this one right here up to switch 1, is our root port, and it's forwarding. And that root port is the best path to the root bridge. It has the best cost to the root bridge, as we can see 19 right here. And the alternate port is in the blocking state, and that is the port to switch 3. And it's in the blocking state, in the alternate state, just in case this port right here to switch 1, which is the Fast Ethernet 0 1 connection, is taken down for some reason. Switch 2 will still have an alternate path, which would be through Fast Ethernet 03 to get to the root bridge, which will be switch 1. So that is why we have root ports, which is the best current route to the root bridge, and the alternate port is a backup just in case the root bridge goes down. It'll still have a path. Okay, so let's see what Boson is going to say. It says the root port is chosen by determining which port has the lowest path cost back to the root. The lower the path cost, the better the path. Therefore, root ports represent the best path to the root bridge. All switches except the root bridge contain exactly one root port. Root ports are eventually placed into the forwarding state. And right here it says an alternate port guarantees a path to the root bridge if the current root port becomes unavailable. Alternate ports are always placed in the blocking state. In the blocking state, PVST prevents the port from forwarding traffic. All right, that's good information to know, and that's kind of what I just explained. So number 3, it says, why on the Fast Ethernet 01 interface on switch 2 why is the Fast Ethernet 01 interface on switch 2 chosen as a root port instead of the Fast Ethernet 03 interface? Well, I just explained this, but if we look at the cost for the Fast Ethernet 01 interface up to the root bridge is only 19, and we can see the cost for the Fast Ethernet 03 interface is 38, and that is because Fast Ethernet ports by default have a cost of 19. So it's only one Fast Ethernet link up to switch 1, and we have 2 through the Fast Ethernet 03 connection. It has to go through 03, and then it has to go through 01 on switch 3. So that's 19 plus 19 is 38. So we only have 19 for the one link, and then 38 for the 2 traversals of the Fast Ethernet ports if we go through the Fast Ethernet 03. We only have 1 for the Fast Ethernet 01 up to switch 1. All right. So right here on number 4, it says what port rows exist on switch 3. So if we go to switch 3 also has a root port. Of course, it's only going to be one root port on all 9 non-root switches, and that is the best cost to the root bridge. And then we have a designated port as well, and that is to send. It's also going to be forwarding traffic as well. So let's see what Boson is going to say. It says a designated port is a port on a segment that has the lowest path cost to a non-root bridge. Designated ports are eventually placed into the forwarding state. So yes, we have a root port and we have a designated port on switch 3. That is the connection over to this non-root switch right here, which is switch 2. All right. So number 5, it says, why is the Fast Ethernet 01 interface on switch 3 chosen as a root port instead of the Fast Ethernet 02 interface? And that's exactly what I just explained earlier. The Fast Ethernet 01 port has a cost of 19, and that's straight up to the root bridge. So that's only one link it has to traverse to get to the root bridge. And the Fast Ethernet 02 port has a cost of 38, and that's because it has to go through the 02 port to switch to, and then up the Fast Ethernet 01 port to get to the root bridge. So 19 plus 19, which is the default port cost for each Fast Ethernet port, is 38. All right. So that is why, and that is greater than 19. So that is why the Fast Ethernet 01 port is chosen as the root port. All right. So right here it says, why is the Fast Ethernet 03 interface on switch 2 blocked instead of the Fast Ethernet 02 interface on switch 3? So if we take a look, both of these paths, which is Fast Ethernet 03 on switch 2 and the Fast Ethernet 02 on switch 3, both have a cost of 38. All right. So then we have to take a look at the ports. And if we take a look at the ports, we can see on this end, this is a fast Ethernet 03, and this is fast Ethernet 02. So if we take a look at the priority numbers, this has a port priority number of 128.4, and this has a port priority number of 128.3. So because of that, switch 3 is going to be forwarding and switch 2 is going to be blocking. All right. So yeah, it says right here. Both interfaces have the same path cost of 38, which I just explained. And then it says when the paths are equal, port priorities must be considered, which is what we just did. The ports with the lower port priority will become the designated port. However, they're both are 128. And then it says right here, when the port priorities are equal, the port number is considered. Yes, that's what we just looked at. On these switches, the fast Ethernet 03 interface on switch 2 has a priority of 4, and the fast Ethernet 02 interface on switch 3 has a priority of 3. Because the fast Ethernet 02 interface on switch 3 has a lower port number than the fast Ethernet 03 interface on switch 2, the fast Ethernet 02 interface on switch 3 becomes a designated port, and the fast Ethernet 03 interface on switch 2 becomes the alternate port. All right, so that's exactly what I just explained. All right, so we took a look at those priority numbers within our output. All right. So now, task 3, it says influence the STP root bridge election process. It says in this task, you will modify the priority values on switch 2 and switch 3 to influence the root bridge election process. So right here it says on switch 2, issue the command to modify the per VLAN spanning tree plus PVST plus VLAN 1 priority to a value of 16,384. So if we go to switch 2 and we do a configure terminal and we do a spanning tree VLAN 1 priority, we do 16,384, hit enter there. Now it says on switch 2, issue the command to display the STP parameters for all VLANs. Which switch has been elected as the root bridge for VLAN number 1? So if I do a do show spanning tree, we can see that now switch 2 is the root bridge from this output. And we can see that its priority is 16,385. We can see its MAC address right here. And also all of this information in the bridge ID matches all of this information in the root ID matches the bridge ID on switch 2. And that is because it is the root bridge. As we can see, the rows on each port on the root bridge, which is switch 2, are designated. All right. So yes, that looks good. All right. So it says right here on switch 3, issue the command to configure the switch as the primary root bridge without specifying a numeric value. All right. So let's go to switch 3. Let's go with configure terminal. Configure terminal. Let's do spanning tree, VLAN 1, root, primary. Hit enter there. Now it says right here on switch 3, issue the command to display STP parameters for all VLANs. Has switch 3 been elected as the root bridge? What priority value has the switch been assigned for VLAN 1? So let's do a do show spanning tree. And we can see that switch 3 is the root bridge by this output in the root ID. It says this is the root bridge. And we can see the priority that was configured is 12,289. All right. So that looks to be the end of this lab. So let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.